Okay, welcome. My name is Robert Cristian. I work for Q Catalyst, and this is presentation about a buzzword, serverless, and it's somewhat specific to AWS, Amazon Web Services. So, just to get past my imposter syndrome feeling, so how many of you know about this stuff? Raise your hand. Okay, so that's good enough. Hopefully there's something to learn from me, for you. Alright, so this is what's on the agenda. We're going to talk a little bit about what serverless is, and then why we should pay any attention to it. Then, simple example, there's some code that we can take a look at, tools, and what to expect being a developer to happen when trying to develop on this technology. Then we're going to resume to talk a little bit about why serverless, because now we have the example, we've seen some stuff, so maybe we can think of other benefits, and then the downsides, because obviously not everything is peachy. Then we're going to look at some patterns and try to discern whether some sort of application is good or fit for serverless approach or not. Right, so that being said, what's serverless? And there are a lot of definitions out there, and mine is, to add to the existing ones, mine is that there's no persistent application server. And I'll have to define a little bit what an application server is, because, kind of in the Python world, it's not that common to talk about an application server, I believe. The scenario is quite simple. So in the classical way, let's say, you have a client, usually a web browser, a client, what have you, that connects to that application server. So that application server probably has access to some data, a database, and that's basically your flow, right? The application server will process your request, get some data from the DB, and return it back to the client. Now, serverless is that basically the client connects to the cloud. Now, what happens in this particular case remains to be discussed. Now, a little bit about the application servers. So, what do? They handle requests, of course. You might think is like Apache or Nginx an application server. Well, not really, because you only know how to handle HTTP. But application server usually do more than that. So that's a little bit of state management that they might do, and they might also handle security and authentication for your requests. That's only a couple of things that you might get from an application server. And why I make this distinction between an application server and like an HTTP server will become obvious in a second. So this is, anybody know what CGI is? Have you ever programmed, like, develop a web application with CGI? Okay. So this depends on your age, actually, because if you're old enough, in the 1990s, CGI was how you do web stuff, and you basically had at your disposal a web server. So things were really simple. Like you had the client, the web browser that would issue a request to a web server, and what would happen there is that the web server would fork, so create another copy of the process, execute some script. Usually it was Perl. Okay, that was the main tool to do this kind of stuff. And the request handler got the HTTP parameters in the environment variables, but you had to do a lot of processing because they mainly came in raw. So then the request handler would do some computing, basically build your web page, and then return it via standard output to the web server, which would then return it to the web client. And this might seem very familiar because Whiskey is actually CGI on steroids, right? So it's basically the same stuff, but they kind of made it better. So there's a protocol that's going on, and it's easier to process requests. Now, this guy is saying that Amazon Lambda, which is basically the core of everything serverless, is like CGI, and he is actually right. And it's the exact same execution model. So, thinking of this model, applying it to the serverless world, it means that you're basically going to replace the web server with something that would become like an API gateway, right? So something to handle your HTTP requests, and then when your HTTP requests come in, then you're going to execute a function. And they call it the Lambda function because I suppose they took it, it was inspired by Lambda calculus, but it's the exact same, not quite actually. It's kind of like what you get in Python for a Lambda function. It's a function, it executes, barely has a name, but it produces some sort of an output. Okay. So the flow, again, doesn't change much. Request from client through the API gateway. A Lambda function is executed, computes something, returns something back to the client. So nothing new in there. But then, as I was thinking, as I was saying, we pretty much need to redefine what an application server is, because you obviously need a little bit more than just painting the HTML page and returning it to the client. So you need state management, for instance, authentication. This is something that an application server could do. Oh, one more thing. I nearly forgot about this. So you see the problem with this model is in the handler when your program or your script is actually big, is a big chunk of work, right? So the best example to illustrate this issue would be with Java environments, for instance, right? So let's say I write Java. Right? So the JVM, the Java virtual machine, will take like forever to start up. It has a boot time that is amazingly big, right? So it wouldn't work with this model really well. Because each time, I cannot afford, each time a request comes in, to spawn a new JVM, right? That would make any request take like 5 seconds or something like that. And so obviously, they needed a solution for this. And they thought, okay, we don't like processes, lightweight processes, but we're going to like we're going to go with threads, right? So you have this process that's always on, but then every HTTP request is handled by a thread in that application server. This is how application servers actually were born, right? And then we started putting in like authentication, state management, and so on and so forth. Now, with serverless stuff, all these authentication, state, and whatever service you would need for your application, you would have to build it from what the cloud provides. Actually, Amazon provides a lot of small components, small services for most of your everyday needs. So like you need to handle state, okay, you can use Redis, for instance, right? That's a good choice, or Memcache. And they do provide a service for that. It's called Elastic Cache. It wraps either Redis or Memcache or what have you. And you can manage state in there. So authentication may use their service called Cognito, I don't know. Or maybe something like Auth0 or something like that. So you pretty much have to do a stitch-up job. Right? All those services, they all have APIs. You'll have to construct your application by stitching up those services that are already there for you. Right? So, by the way, ask me anything, anytime. Just don't wait for it. Right? So this is what Amazon says about what serverless is, and that's a link to one of their presentations. So they say, okay, you won't get an application server or something like that, but you get those simple but usable primitives like Elastic Cache, or it's simple, it's really simple. There's no wrappers around it or something like that. You just kind of get the raw stuff. It just does what it does, store things in cache, but it does it really fast, and of course they manage by Amazon by being a multi-tenant, right, provider. So they use it to make this be really, really cheap. Okay, it scales with usage. What does that mean? I can start 1 Lambda functions. I can start like 10 Lambda functions, depending on how many requests I need to handle. Basically, I can start like a lot of Lambda functions. Never pay for idle. This is something we'll talk about. And then you get availability and fault tolerance that is built in. This is about infrastructure, right? You don't have to manage any of that. It's there. They manage it. They make sure that your Lambda functions won't crash, or they'll run within some parameters that they define. So you get some sort of service level agreement. It's not really nailed down to exact numbers, but I would say it's kind of like good enough. It's more likely that they do a much better job than any of us would do in managing the infrastructure. That's for sure. All right, so why go this route? Because it's cheap. This is the first reason, right? So the thing is, you never know when your requests will come in. So, and you always get like those traffic patterns for your application. Like if my customer base is in the US, let's say, that means like half a day or night, if you will, there's going to be basically no traffic because nobody, surfs the internet at 2 a.m. I guess. So you get. Sorry?
Not your site anyway.
Right, yeah. So actually, no one surfs your site. Okay, so you get those traffic patterns, And this is the big difference, because if you keep one server running 24 by 24, you know, it will eat up all those resources, at least current or something like that. So you'll have to pay for that. For maintaining that server, for running that server, costs something. With Lambda, you actually pay only for what you use. So how do they manage to do that? It's actually pretty simple. Let's say you have one machine and it serves basically 100 customers, right? So that's like time sharing that's going on that box for those customers. Amazon's capabilities and any cloud provider capabilities are that they can manage that time sharing or resource sharing table in such a manner that you can run your stuff, and they will make sure that when you need to run your stuff, there will be always some resource available to serve your requests. So that's why it's cheap. If they are not serving you, then they might serve Yonel site or something like that. Okay? So it's cheap. So how cheap is it? Yeah.
If you get to 100% usage, and you need to scale it up from 110 sources,
Yes. Well, it depends. It depends on the scenario, right? So if you know, like, you have to do transcoding, so video asset management, that's something you might not want to do with Lambda. I mean, not do it yourself. They do have a service that can do that, so you can look into that. It's only that you would say, transcode this video for me, and then you pay for that service. But if you want to do it yourself, then it might be better to look at something. Okay, I need to have this instance running in the cloud, which transcodes video, because I pretty much know that the CPU will be 100% all the time. So you have to look at the costs, right? So how cheap is this? It's very cheap. Look at those numbers. So it's like 5, 6 zeros and then a 2 on a per request. Extremely cheap. And then you get 1 million requests for free. That's cheap. You don't, you have to have like pretty big traffic to beat that. But and there's always a but. This is unless you follow some anti-patterns. So this cheapness might just go away which we'll see a little bit later. Alright, so let's look at some simple examples to get the feeling on how programming serverless style would look like. And this is simple, maybe it's stupid, I don't know, but let's say we have this situation where there's a batch of work to be done, and then we need to do a computation for each of those lines, right? So, like, it kind of resembles memoization. I have a typo, sorry. Where you would cache the result of an operation, right? So 1 + 1 = 2, 2 by 2 = 4, and so on and so forth. So how would I do that? Right? This would be how I should think of solving this issue. And it's kind of, it is a little bit different than thinking, you know, the old way, like the old way, in the classical way, like just do it. But you have to break up work into smaller chunks, right? So you break up those ops array into multiple work pieces, right? And then there's a process that would ask for more work. Is there any new work to be done? Yeah, there is 1 + 1 to be computed. Okay, so launch a new lambda for that. There's 2 by 2 to be computed. Launch a new lambda to compute that. That's it. There's very small, very granular operations that we need to do, right? So we can think of, you know, where do we store all that stuff? I know, you know, we need some sort of state, I guess, or, you know, need to know what the work to be done is. So we're going to store the initial batch of work in S3, and I kind of suppose you know what S3 is. It's kind of a file storage that Amazon has where you interact with the file system via HTTP requests. So like, get me this file, put this file, and so on and so forth. And we're going to store that JSON into one of a bucket in S3. That's like a directory in S3. And then upon, so we're going to fire up a lambda that will break that JSON into smaller chunks, will create a file for each of the computations that need to be done, store that in another bucket, and then we'll have a lambda that will be triggered by the event in the bucket. Like, there's new work to be done, there's a new file in that bucket, and we'll compute the result. So hopefully let's see how it's implemented, and see what we get into code. And I need to hurry up because there's less time. So this is the bread and butter of using the serverless. It's not a framework, let's call it a framework or a library. It's a service, a tool that allows me to set up everything in Amazon in order to compute those kind of things, right? So what it does, this is where you configure everything you need, right? And there are some important things to note in here. And the most important one is that besides code, you don't have only code in your application. You have to describe how your application will get deployed, right? So what resources does it need? The application is not only code. It's, you know, usually, like, you build your application, you try to run it, but then you find out, you know, a database connection is needed or something like that. You don't have that configured. Well, this is a little bit better, because this is where you say what resources you need. So you're gonna say, I'm gonna need I'm sorry. I'm gonna need I'm gonna need a bucket that is the place where I will put that batch of work. I'm gonna need the bucket, an S3 bucket, for the work that needs to be done. So 1 by 1, 1 + 1, 2 by 2, and so on and so forth. And then I'm gonna need the bucket to store the results. So it's like declaring your infrastructure. And there is other stuff as well, because you need to handle security. So you're going to say something about what security you need. And this one says, you know, I need access with my Lambda functions to those buckets, and because I need to read from them, I need to write to them, and so on and so forth. So basically declare your infrastructure, define your security, and this is part of your application. Right? And the bread and butter are actually the handlers. Right? So we're going to have this is a hello function. We won't get into that, but I'm going to need two Lambda functions. One of them is something that will break up that JSON file into smaller pieces and will store the outcome into S3 files. So this is one of our Lambda functions, and this is how you trigger it, right? So this says we're going to invoke that Lambda function via an HTTP request, and with a method, with a get method, it should basically do this start work kind of thing. Right? And then we need a function that will actually compute what 2 by 2 and 1 plus 1 is. Right? So this is triggered a little bit differently. This is triggered by an event and S3. So is there a new file that gets created? Yes. Okay, so that means I have some computing thing to do. Right? This is our this is how everything comes together. So basically, you're describing your interactions with your environment, how you're going to handle stuff. And the code for this is fairly simple. Right, so that start work. Is this big enough? That start work handler, what it does, it gets an object from S3, and this is our work file, basically that JSON, right? So for every operation in that JSON, we're going to create a new S3 file in another bucket, right? As far as that, as long as that file is created, then an event will get triggered, and this compute function will be called. And this, what this does, basically evaluate the expression, so 1 times 1 plus 1, 2 times 2, and so on and so forth, and store the result in another bucket. I can show you how this looks like. So this would be something I would get in the work bucket. This is the JSON which specifies the operations, and then another bucket with each individual piece of work, and then the results bucket. So if I download this file, it's going to be, say, 1 plus 1 equals 2, 2 by 2 equals 4. Yeah.
How many threads?
Well, there are no threads. There are lightweight processes. So everything is event-driven, right? So you don't really know when exactly those events will get triggered, but you have 2 requests, 3 actually, right? So one that starts the work, so I process this, and then 2 events from S3 will get triggered. Like this file got created 1 plus 1, and this file got created 2 by 2, right? So you'll have 2 other Lambda functions that will trigger at that point. It's pretty fast. So
it would have like 10 million in the settings.
well, there are limits. Yeah. So currently, Amazon restricts that restricts parallel execution of Lambda function to 1,000 requests in parallel, right? So there are limits. You can call them
custom tracking.
Sorry.
Custom tracking. So you can say that
Yeah. Yeah. You can call them and say, look, I need more.
No more, less.
Less.
Like
Yeah. You can say,
tracking.
yeah. The reason they have this limit is actually because you can pretty easily denial of service yourself, right? So, like, like event-driven programming is something of sometimes it's voodoo work. You just don't know when those events will get triggered, right? So you might get like a blowout or something like that, everything. Events get triggered, you start processing them, Lambda functions, calling other Lambda functions, it can get really chaotic. So they have this limit because they can say, that's enough.
Do you ever get like the infinite loop?
Yeah. That's very easy to get.
So how do you fix it?
Well,
Go deeper to
so give you an example. So, like in this really stupid example, what happens if I write to the same bucket, right? So I store the results in the same bucket. So I basically create like an infinite loop, right? It's going to go spin up a lot of Lambda instances. It's going to go forever. But that 1,000 limit will actually stop me at some point. So you'll say, sorry.
1,000 per second.
It's 1,000 at a time, right? 1,000 in parallel.
Yeah, but you still have the loop.
Yes, but
It's slow.
depends on how many files I write at one time, right? So it can go exponential, right? So if 2 files will generate 4 files and 8 files and so on and so forth to basically explode. You can get into that kind of situation.
It's like small data.
Yeah. So that's one of the things you have to be very careful about, right? So we went through this.
Can I ask something?
Yeah.
In case of a real application, you have to upload your code to the server and then provide an interface method to use.
Well, this can be handled by this serverless tool, right? So I can code everything locally, but then I'm just gonna go make deploy, and hopefully this won't. So it will basically pack everything up, because you can do it manually. You don't want to do that, and I'll show you why. After deploying, you'll get this nice thing where everything is packed up in a CloudFormation stack, right? So what this does is something that it depicts all the resources you're using, right? So it's a collection of everything your application uses. That's the benefit of using a tool. If you do everything by hand, you're not going to have this, right? But this clearly states that I'm using like those buckets and those Lambda functions and so on and so forth. These are all the resources that I'm using. And then I can go like, you know what? I need to clean up, like delete, right? So what that would do is clean everything up. So I'm pretty sure I don't have like leftovers or something like that. And that's something what the serverless tool does. Right? It will create this cloud formation definition that will include all your resources. And cloud formation is the language that Amazon uses for defining your resources. It's kind of like a translator for what you put into that serverless YAML file and cloud formation. Did I answer your question?
Yes.
Right. So, okay. So, what does this thing mean for the Joe programmer? So, you have to do in terms of testing. This is kind of like an awkward domain. Unit tests, the usual, right? It's just code. Import PyTest something, test everything that you need to do unit tests for. But then integration testing is a different kind of a beast because there's limited support for running this thing locally, right? So some may say this is good or this is bad, but actually I can run there are plugins and tools that will kind of emulate what Amazon does in terms of services. And this is one example where I have a couple of plugins that emulate the Lambda engine and the S3 functionality, so I can really kind of test locally and see what happens. So this works, but if you look at the console, there's a crash. And actually, the serverless tool doesn't seem to do a good job working with Python and virtual environments. So tough luck. If I would have written my code in JavaScript, then this would work. So, but there is hope. They're kind of working on tools, and Amazon is doing that as well. So they're working on tools that would bring the cloud functionality to your computer. Right? But good or bad, it's kind of debatable. So if you look at it from some perspective, you might think that having to deploy to the cloud every time you need to do integration testing is actually a good practice, right? Because developers usually do like, I need to write an integration test for this. You know what? I'm just gonna check it real quick if it runs on my machine, right? So does this API work? Yeah, it does. Yeah, screw that. It's fine. So no integration test for that. So the minute you deploy, you find out that actually it breaks because you did something in the database or there's something special about your machine, which usually happens, right? So you might say this is actually good practice. It's kind of preventing you from doing mistakes and actually taking good care of your integration tests. It's debatable, but and thing is, you can deploy to any number of environments, right? So I can have my environment, Florin can have his environment, we can do cleanup at any time. So the thing is, they're both production-like environments because I can promote that to production. You just need to scale it up a little bit or tune the parameters, but it's really a production environment. Right? So this is one of the advantages because kind of like each developer gets their own production environment to play with. So, software development lifecycle. Well, that's it, tongue twister. Okay, so what does serverless mean for the development? These are the highlights. So you have to really understand your cloud what your cloud provider provides in terms of services, because you'll have to stitch them up. You'll have to use them, like Elasticache. Does it have like a state management service? Yes, it does. It's called Elasticache. Does it do authentication, authorization, cognitive, something like that? So you have to know those things. So it's not like, I'm done programming and then throw it over the fence to the ops team, and done, take care of it, bye-bye. It's not like that. You have to really understand what your cloud provider does. So the next big thing, and actually I think this is the most important, you have to think your application's architecture in terms of being event-driven. So events are, what binds Lambda functions together. So everything in Amazon, and not only Amazon, but Azure as well, Google as well, everything, every service they provide triggers events. All of them do. Like DynamoDB, new record inserted, you can get an event for that. Record deleted, you can get an event for that. S3, put file, get an event for that, and so on and so forth. So you have to think in terms of handling events, which is, not many folks, programmers, know how to handle that very easily, and it's arguably kind of difficult to do and difficult to test. But so the next point, testing, just feels a little bit different because sometimes you cannot run properly tests on your machine, but as I said, that might be a good thing.
How is debugging things?
Well, yes, it's hard. Yeah, I say
How hard?
very hard. I'm going to show you. So basically, what you need to do is they provide some tools for answering the question, what the hell happened? But they're pretty primitive in nature. What they can do is they can trace a request, right? So you have this feature called X-ray. And why is it not here? Okay. Let's see what's going on. Okay. Alright, I got something. So you have this feature where you can trace requests. It's got an API if you want to follow that. Otherwise, just log into the console and take a look here. It will basically tell you, what Lambda function triggered what, and it will trace your requests across Lambda functions. Yeah. So
you wanna
there is something.
bug in your function. When you do tweets, basically.
Yes, more or less. Yes.
Can you run a tracer?
Yeah, you got logs for, you have logs for each of your Lambda functions. So you can go to the log group of that function and kind of, what happened. So you do prints. This has an API, everything has an API. This has an API as well. you can speed them out in something like an aggregator or something. There's that. But this is something you need to kind of figure out how to do. But you know, how would you test? Would it be better if you could test event-driven stuff locally? I think it still will be prints or something like that. You know, stuff firing all over the place. This is an issue.
Does the Python runtime have limitation, like not being able to see set phrase, things like that?
Not really. It's kind of like a full Python runtime. There's no limitations. So you can do that.
Is this compatible with HTTP?
I think it is.
Because HTTP is fully asynchronous and events are asynchronous.
Okay. I'm not sure. I have to look into that. So, this is a question, I think, for the API gateway rather than for the lambdas, because the API gateway is the service that handles your request, and I don't know that. So, all right. So, why serverless? Because it has small operational costs, and we've seen why that is. It's fairly quick if you want to build something small. So the example application took me like maybe half an hour from scratch to deployment, something like that, and then I had bugs, and Korea helped out. And you don't have to worry about too much about the infrastructure because it's handled by the cloud, right? They do everything. Availability is built in, and there are small operational costs, right? You don't have to update your Linux box or something with the latest patches because there's some HTTP, some SSH problem bug that wasn't fixed in 20 years or something like that, right? So, right, so why not? Obviously, vendor lock-in. So, but this is, again, questionable, because if you want to migrate all this stuff to Azure using a tool like serverless, you're just going to have to change the provider and that serverless YAML file, and there's not a lot to change, I guess. But you'll still be dependent on the cloud. It's not your application to have anymore. Right? So you cannot show it to your parents if you're offline. Right. So testing, again, this is questionable as well. It's pretty bad of an experience right now, but then again, event-driven development is hard. It's hard to develop, it's hard to test. And debugging, again, there's a limited set of tools that allows you to do that. So, but there's progress that's happening right now on improving on all of those. AWS SAM Local is something that Amazon develops and is kind of like a local. You get your local cloud simulation of their services on your local machine. So that's good. I haven't tried it, so if it works. Oh, backups. When would you want to use those? Stitch up jobs, right? So you have all those services. This is a pretty basic example. So you have to aggregate something that comes from Google, GitHub, Jira, something like that. This is an obvious solution because everything has an API, right? There's only this much code that I need to write. Is fetch some data from those data providers, do some aggregation, store that in a warehouse, something in a database, and then have this really nice UI that shows you, your data. This is one of them. And usually, as this, I mentioned, like usually you have a thick UI. When thinking like single page apps where the application loads with one request. There's no server-side rendering or something like that. Okay. This one is actually quite important because let's say this is a scenario where you would have an established product. It has some API, it has some UI, but you want to know whether a new feature that you want to bring in would make sense or not, right? So what you do, you develop this new API and this new UI, like next generation UI, and you want to test that on your customers. And this is really, really, really easy to do with serverless because you just spin up a new Lambda that will bring out the new UI, some new data that you can stitch into your user interface. So it's very good for this kind of thing. It doesn't work, kind of throw it away. There's that. Try again, right? And then data processing pipes. This is good as well. So everything is event driven, so it naturally fits into this pattern of ETL, extract, transform, load. Right? So you're fetching data, you do something with it, you do something with it, you do something with it, and everything is event driven. But there's new data to be processed, there's new data to be processed, so on and so forth. This is very, very suitable for it. Empty patterns. So server as a function, what does this mean? Many of you, I think, want to ask if you can run your Django application on this. Yes, you can. There's a framework for that. It's called Zappa, and it will basically run everything that knows how to handle whiskey, right? So Flask, Django, what have you, right? But I would say that's kind of like an anti-pattern because your application, your Django application, comes with all the bells and whistles. It's kind of heavyweight. Why put that through a Lambda function? Beats me. Because, startup time, that will take a lot, right? And then it's not going to be cheap anymore. Right? It's not going to take 100 milliseconds to serve one request. One request is going to take 500 milliseconds, and that will hit your credit card really fast, right? So that's not good. Too many, too granular functions. Kind of, imagine like as you had callback hell in JavaScript, it's kind of the same. You have grains of sand to deal with. You don't know what does what. It's the same issue that we would see with developing with microservices, where you kind of go to the butcher and have these really small pieces and you don't know what's there anymore. Right? Functions calling other functions. This is bad because the first function won't exit until the second function exits, and so on and so forth. So you're getting that DOS yourself kind of issue, most probably. And then again, it's not really a good programming idiom, right? Because as I mentioned there, you're kind of blurring the line between domains of concern, right? So and then long-running functions again won't be cheap anymore. Kind of the same thing as server as a function. Right, and there's obviously limits on what you can do with Lambda. There's a link in there. One of them is that 1,000 simultaneous requests. Should I learn it? Yes, I would say yes. Because the way managers see this, it adds a lot of business value. Everyone likes cheap stuff, and this is cheap. And then there's fast time to market. Right? What that means, you can prototype fairly quickly, and there's not a lot of code that you can write that you need to write, and then you just kind of push it out there, see what happens. Maybe they like it, maybe or they don't. And this is funny. This came in today. If you know Cornell, he draws this kind of stuff. This is, you know, you spend all your budget on building the engine, but then the saddle, the small thing up there, is your application, but you don't have money for that anymore. So this is exact kind of situation where, you know, this is, you know, you should go serverless. Don't reinvent the engine, don't reinvent the wheel, because you have everything in there. Like you have operations that the cloud takes care of. You have everything in there, so no time to reinvent the wheel. Ask me anything. I don't know if we have time for that. This was kind of fast, but where's the sample code? I need to make this public, but and how to get started? Well, this is actually worth talking a little bit about, because you need access to Amazon, and you know, if your employer doesn't provide access to Amazon, is it worth to punch in my credit card number and kind of start playing with this kind of stuff, because you have to put in your card number, well, your credit card. But the thing is, it's really cheap. So, you know, for your test app, and there's a free tier. So you're for your testing, for your playground, you're most likely to pay nothing at all, or maybe like if you're like the power user or something like that, maybe pay like $5 per month or something. It's really, really cheap. And then tools, you can Google for those. I don't know how to pronounce that. Calis. Right. Okay. That's something like serverless, but it's written in Python. Local stack is you get a version of Amazon services running on your local computer. Didn't try that either. I don't know if that works. Maybe it does, maybe I don't know. But I would kind of rely more on what Amazon builds, because they can keep things in sync. Any questions? Or maybe after the next presentation would be better, because we're way over time. I'm sorry for that. Thank you.